Hi everyone, welcome to Go Classes. In this session, we will discuss weekly quiz 31. In this weekly quiz, our subject is digital logic and all the questions are from Multiplexer. Okay, let me tell you one thing that in this quiz, in this weekly quiz 31, all the questions, each question is taken from Gate Electronics, Gate Electrical, Gate Instrumentation PYQs. Okay, so remember every question in this quiz, in this weekly quiz 31, every question, every multiplexer question that we have taken, that is taken from Gate EC, Gate EE, Gate IN, previous year questions. Okay, so let's start now. Let's start with this session, this question. So let's solve this question. This is Gate Electronics 2011 question. You can see the logic function implemented by the circuit below. Ground implies a logic 0. This ground symbol, okay, this symbol, remember this symbol, this implies logic 0. Okay, this symbol, remember this ground symbol, this symbol means ground symbol. This is known as ground symbol. Ground symbol. Okay, and what this symbol indicates? This symbol indicates, this symbol implies a logic 0. Okay, so this symbol means a logic 0. Now this multiplexer is given to you. The question is asking what the function implemented. The question is asking what this function. Okay, so let's solve it. You can see these are the select lines. On the select line S1 S0, on the select line you have two variables. These are the Boolean variables. You can see these are P comma Q. Okay, now tell me what is I0, I1, I2, I3. What are these? So you can see this symbol means ground symbol. That means logic 0. You can see here ground implies logic 0. Now there is a NOT gate. First of all, you can notice this 0. So this I3 is equal to 0, right? Yes or no? You can easily see that I3 is equal to 0. This multiplexer is given to you. In this multiplexer, you have S1, S2, S1, S0. These are the select lines. On these select line, we have these Boolean variables. These are PQ. These are the Boolean variables. The question is asking what the function implemented. And the question is saying in this multiplexer, you have I0, I1, I2, I3. These are the inputs. You can see these are the inputs. Now, what is I3? I3 is equal to 0, right? Yes or no? I3 is equal to 0 because you can see this symbol, this ground symbol means 0. This 0 is directly connected to I3. Okay, this 0 that is directly connected to I3. What about I2? You can see I1, I2, these are 1 because here you will have 1. Okay, there is a NOT gate here. There is inverter. So this is your inverter. So you can easily see that here you have the signal 1. Okay, here you have logic 1. This logic 1, this is connected to I1, I2. So I can say I1, I2, that is 1, 1. And what is I0? What is I0? Again, there is an inverter. Again, there is an inverter. So I0 is equal to 0. Okay, so this is your multiplexer. Very simple. Now, from this multiplexer, you can easily write what this function f. If you notice one thing, these are your select lines, S1, S0, these are PQ. And these are the inputs, I0 to I3. These are 0, 1, 1, 0. So what this function? You can easily notice this 0, 1, 1, 0. This is your exclusive OR. This is the truth table of exclusive OR. Correct? Okay, so you can easily notice that F is equal to exclusive OR of P comma Q. Or if you want, you can create the truth table and you can find it. So from here, you can say that F is equal to, you can see when both are 0, then this I0 will be activated. Yes or no? Yes or no? See, when both are 0, PQ, when both are 0, 0, then this I0 will go to the output. I can say this F will be equal to I0. Yes. Similarly, when P is 0, Q is 1. When this P is 0, Q is 1. Because remember, this P is connected to select line S1 and this Q is connected to select line S0. Okay, yes or no? So when P is 0, Q is 1, then this I1 will go to the output. I can say F will be equal to I1. When P is 1, Q is 0, then this I2 will go to the output. So I can say F will be equal to 1. And when both are 1, then this I3 will go to the output. So I can say F will be equal to 0. Okay. So easily you can write the equation for F. That will be when both are 0, when P is 0, Q is 0, then in this situation, the function value that is 0. Okay, function value is 0. Or When P is 0, Q is 1, then the function value is 1. When P is 1, Q is 0, then the function value is 1. When P is 1, Q is 1, function value is 0. Okay. Now you can easily see that function value that will be equal to P bar Q or PQ bar. That is your exclusive OR. That is P XOR Q. So your final answer will be P XOR Q. Okay. So you can see XOR P comma Q. That is your final answer. Answer will be option D. So this is a very simple question. GATE Electronics 2011 question. Okay. Now let's move on. Now let's solve this question. This is GATE Electronics 2020 question. In this question, a multiplexer is given to you. The figure below shows a multiplexer where these are the select lines. You can see S1, S0. These select lines, you can see these are connected to PQ. Okay. Where S1, S2 are the select lines. Actually, I think there is a mistake here. This should be S0. This should be S0. Okay. S1, S0, these are the select lines. So this is a mistake here, that this should be S0. So you can see S1, S0, these are the select lines. Next, I0 to I3, these are the input data lines. This enable, this EN, this is the enable line, and this is the function that is implemented. The question is asking what is this function? The question is asking what is this function, and options are given to you. You can see the options are given to you. Okay. So now let's solve this question. First of all, in this question, you can notice this enable. Look at the enable signal. Okay. In this multiplexer, you have a enable signal. This EN, this is the enable line. Now you tell me, is this active low or active high? This enable you have enable input. This input you have enable input. So tell me, this enable input, is this active low or active high? You can see this bubble implies active low. Yes or no? This bubble implies active low enable. This bubble implies active low enable. Active low enable. What that means? Active low enable. What that means? So remember, this enable is active low. This is active low enable. What that means? Tell me. This is active low enable input. So that means that it will be, I can say this multiplexer will be working when this enable will be low. Yes or no? Active low enable. What that means? It means that when enable is low, low means 0. Okay, when enable is 0, then mux will be working. Then this multiplexer will do the normal working. Okay, will do normal working. Okay, normal working as it does. So you can see, yes or no? Very simple point. I am saying that look at this circuit. In this circuit, you can see there is an enable input. This enable input is given to you. This bubble indicates active low enable. Okay, this bubble, here you have a bubble. This bubble indicates that this enable, this is active low enable. And what active low enable means? This means that when this enable is 0, when this enable is low, then this multiplexer will perform its working, I can say. Then the multiplexer will do the normal working. Okay. And you can notice already it is given to you that enable is 0. So tell me, because it is given that this enable input is 0, then tell me, then what will happen? Then multiplexer will work normally. Yes or no? Then I can say multiplexer will work normally. Multiplexer will work normally. Yes or no? So you don't have to worry about the enable signal. This enable signal, you don't have to worry about it. Okay, because it is already given that this enable signal is 0. Okay, and this bubble means active low enable. Okay, and this is given that enable signal is 0. So you don't have to worry about the enable because the multiplexer will work normally. Okay, so you can forget about this enable now. This enable, you can forget about it. Okay, just forget about it. Now you can perform. Now you can just analyze this multiplexer normally. Okay, just don't worry about the enable signal because this is an active low enable. And you can see because it is given that this enable signal is 0, input line, this enable input is 0. So this multiplexer will behave normally. This multiplexer will work normally. It will work normally. So you can forget about this enable, and now you can analyze this multiplexer. So let's analyze this multiplexer. Now you can easily notice the question is asking what the equation of f. So what will be f? Tell me. From here, from this, you can see f will be equal to, remember this variable p, this Boolean variable p, this is connected to S1, and this variable q that is connected to S0. Okay, so you can see when both are 0, when p is 0, when q is 0, then this output will be equal to I0. Yes or no? Then this output will be I0. When p is 0, q is 0, then this output will be I0. I0 means R. Okay, so you can easily see this p, q, and this is your output. Remember, this P is connected to select line S1. This Q is connected to select line S0. When both are 0, then the output function, this output will be equal to I0. That is equal to R. Similarly, when this P is 0, Q is 1, then the output will be I1. That is equal to 0. When P is 1, Q is 0, then the output will be I2. That is equal to R. And when both are 1, then the output will be I3. That is equal to 1. Okay. So now you can see that when P is 0, Q is 0, output, this function will be R. When P is 0, Q is 1, then the function will be 0. Function will be 0. Plus, you can see when P is 1, Q is 0, then function will be R. Again, you can see that function will be R. Next, when P is 1, Q is 1, then the function value will be 1. So from here, you can see that f is equal to P bar Q bar R, or P Q bar R, or PQ. Okay, so this is the function. Now these are the options that are given to you. So you can simplify this given equation. So this function you got. What the function that is implemented by this multiplexer? The function implemented by this multiplexer, that is P bar Q bar R, or P Q bar R, or PQ. Okay. Now you can simplify this. So tell me, how will you simplify? You can easily see that from here you can take P out. Okay, you can take P out. If you take P out, then what you will get? You will get Q bar R or Q. Okay, you can take P out. Now you already know this. This law we already know. A or A bar B. Tell me what is that? A or A bar B. A or A bar B. In this situation, what you can do? A or A bar B. In this situation, this A bar you can cancel. This will be same as A or B. Okay, so here also you can see this will be same as P. This will be same as this Q bar you can cancel. Okay, this Q bar you can cancel. So this will be same as PR or PQ. Okay, and here you have P bar Q bar R. Okay, so very simple point that finally what you got that P bar Q bar R or PR or PQ. Now tell me. Now again, here also you can do the same thing. Here also you can do the same thing. You can take R out. If you take R out, then what you can do? Then you will get P bar Q bar or P. Again, you can apply the same rule. You can apply the same rule. Remember, X or X bar Y, that is same as X or Y. You can cancel this X. You can cancel this X. So here also the same thing. You can cancel this P bar. So finally, what you will get? Tell me. Okay, so the final expression that you will get, that will be, so you can cancel this P bar. This P bar will be gone. So finally you will get, I can say PR or Q bar R or PQ. Okay, now you can apply the consensus property. Okay, now you can apply the consensus property. You can see here. Tell me what the consensus property. If you apply the consensus property, you will get PQ or Q bar R. Okay. So finally, you will get PQ or Q bar R. So this is what you will get finally. PQ or Q bar R. You can apply the consensus property. See, what is the consensus property? This consensus property you can apply. The consensus property is like this. If you have AB, with A you have B, with A bar you have C. Okay, notice. With A you have B, with A bar you have C, and these BC are together. Then what you can do? You can remove this BC. So finally it will be AB or A bar C. Okay. So very simple. So this property you can apply, and here you can notice with this Q you have P. You can notice what is happening here. With this Q you have P, with Q bar you have R, and here you have PR. So this PR you can remove. So finally you will get PQ or Q bar R. So this is your answer, PQ or Q bar R. So for this question, the answer will be PQ or Q bar R. Answer will be option A. Remember one thing, if you don't want to do this simplification, then you can apply the K-map also, or you can eliminate by taking the options also. See, you can eliminate the options. Either you can eliminate the options or you can apply the K-map. If you want, you can apply the K-map also. Okay, let me apply the K-map also for this question. So this function f that is given to you, that is P bar Q bar R or P Q bar R or PQ. So this function is given to you. You can simplify this using the K-map also. You can create the K-map. So let's create the 3 variable K-map. This 3 variable K-map you can create. This is your PQR. So you can just mark the area. So this is the area of P. This is the area of Q. This is the area of R. So here you can note this function is given to you. So tell me, let's fill this K-map. This K-map is given to you. Let's fill this K-map. So you can see P bar Q bar R. Okay, this is the area of P bar. This is the area of Q bar. So you can see P bar Q bar R. So that will be, this is the cell. So you can see. So remember, this means P bar Q bar R. Okay, what this means? P Q bar R. What this means? P Q bar R. So this means P Q bar R. This means P Q bar R. And where is PQ? Where is PQ? You can see this is a PQ. Okay, so this means PQ. So remember, this means, what this means? This means actually PQ. Yes or no? This means PQ. Correct? Okay, this means, look at this. This means PQ. Okay. Now, here you can just do the simplification. So if you want to simplify this, you want to simplify, because remember, options are given to you. SOP expressions are given to you. Look at the options. Look at the options. These are SOP expressions. Yes or no? These are SOP form. Look at the options. Options are given in sum of product. Options are given as a sum of product. So you can simplify. Okay. So let's simplify this. So tell me, what are the cubes that you will create? So you can create one cube like this. Okay. This cube you will get, that is PQ itself. And one cube you can create like this. Okay. And what that cube will be? This will be, you can see, this will be Q bar R. So your final answer will be what? F is equal to PQ or Q bar R. This is your final answer. Okay. Is this clear? Please tell me. Let me know. So you can apply the K-map also. You can apply the K-map also. This function is given to you. You can create the K-map and you can solve it. Or you can do the simplification like this. You can do this simplification also. Or you can eliminate the options. You can eliminate the options also. So finally your answer is PQ or Q bar R. This is your final answer. Okay. PQ or Q bar R. Now let's move on. Let's solve this question. This is GATE Electronics 2014 question. A multiplexer is given to you. 8x1 multiplexer is given to you, that is used to implement a logic function, that is Y. Now the question is asking, what is this function Y? Okay, this function is implemented. So the question is asking, what is the function that is implemented? So you can see this is a 8x1 mux. Okay, and these are the select lines. You can see in a 8x1 mux, there are 3 select lines. These are the select lines: S0, S1, S2. Here you can see this S2, this is your MSB. This variable A, that is connected to MSB, and variable C, that is connected to LSB. Okay. Now the question is asking, what is this Y? So you can write the equation for Y very easily. Yes or no? We can easily write the equation for Y. See, if you want, you can directly write, but let me just explain this, that these are the select lines: S2, S1, S0. Now you can see variable A, that is connected to S2. Variable B is connected to S1. Variable C is connected to S0. Okay. Now this is your function Y. You can see when all are 0, then what will be the output? In this multiplexer, this is a multiplexer, you can see. When this is the select line, when all ABC, these are 0, means select line S2, S1, S0, when all are 0, then you can see the output will be I0, and that is 0. Output will be I0, that is 0. You can see I0 is 0. Next, when you have 0, 0, 1, then in this situation, output will be I1, and I1 is equal to D. When you have 0, 1, 0, then the output will be I2, and I2 is 0. When you have 0, 1, 1, then output will be I3, and I3 is equal to D. You can see, yes or no? When you have 1, 0, 0, then output will be I4, and I4 is equal to 0. When you have 1, 0, 1, then output will be I5, that is 0. When you have 1, 1, 0, then output will be I6, that is 1. When you have 1, 1, 1, then output will be I7, that is 0. Yes or no? Now you can write the equation for Y. Now you can write the equation for Y. So what will be the equation? Equation will be like this, that when all are 0, A, B, C, when all are 0, means A bar, B bar, C, A bar, B bar, C bar. When all are 0, then output is 0. Yes or no? When all are 0, then output is 0. Then this function value is 0. You can see. When ABC all are 0, then you can see this Y will be equal to I0. Means this Y will be equal to 0. You can see A bar, B bar, C. Then in this situation, this Y will be D. Okay, similarly, you can notice A bar, B, C. Okay, in this situation, what will happen? Or I can say A bar, B, C bar. In this situation, A bar, B, C bar. In this situation, the output will be 0. Next, you can see A bar, B, C. In this situation, output will be D. Next, you can see A, B bar, C bar. In this situation, output will be 0. Next, you can see A, then B bar, C. In this situation, output will be what? A, B bar, C. In this situation, output will be 0. Next, you can see A, B, C bar. In this situation, output will be 1. And finally, you can see that A, B, C. In this situation, output will be 0. Okay. Okay. Yes or no? So this is just for understanding purpose. You don't have to do this. You don't have to do this, because you can see many inputs are 0. This is 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 0. Many inputs are 0. So remember, this is just for explanation purpose. This is just to make you understand if you have any doubt. Also, this is only for explanation purpose. You don't have to do this. Okay, in the GATE exam, you don't have to create this table. You don't have to write this expression. You can directly write the expression. Okay, let's directly write the expression. The expression will be like this. What will be this Y? Y will be equal to, you can easily see that will be A bar. Okay, just focus on where you have non-zero value. Focus on where you have non-zero value. That is A bar, B, A bar, B bar, C. In this situation, the value is D. Or just focus where you have non-zero value. I3. I3 means A bar, B, C. In this situation, also value is D. Next, you can see next value is this. That is A, B, C bar. In this situation, the value is 1. Yes or no? So this is the point. Now you can see this is your Y. Now you can simplify this. So the equation Y you got, the equation Y, that is A bar, B bar, C, D, or A bar, B, C, D, or A, B, C bar, A, B, C bar. So this is the equation that you got. Now you can simplify this. Okay, now let's simplify this. So tell me, how will you simplify this? Let's simplify. So how to do that? From here, you can take A bar, C, D out. Yes or no? From here, you can take A bar, C, D, you can take out. A bar, C, D, you can take out. So that will be B bar or B. If you take A bar, C, D out, okay, there is A, B, C bar here. Then finally, what you got? This will become 1. Yes or no? This will become 1. So finally, you got A bar, C, D, or A, B, C bar. Is this given in the options? A bar, C, D, or A, B, C bar? A bar, C, D. A bar, C, D, or A, B, C bar. Yes. So option C will be the answer. Okay, you can see option C will be the answer. So very simple question. Remember, the question is very simple. Just for explanation, the question, this is the question that is given to you. Just for explanation, I have created the truth table. Okay, just to explain the behavior of multiplexer. This is a multiplexer, 8x1 multiplexer. In this 8x1 multiplexer, there are 3 select lines, there are 8 data input lines, and there is 1 output lines. Okay, and you can see when all are 0, these select lines, this is the control, you can say. When these control inputs, these are 0, all 0, then this input will go to the output. When all are 1, then this input will go to the output, you can see. So this truth table, this tells you what will be the output for different combinations of select lines. On the select line, if you put different combinations, then what will be the output? This is what this truth table is telling you. Okay, so this truth table you don't have to create in the GATE exam. From this truth table, you can write the expression like this. This is the expression for y, this is the expression for output. Again, this is just for explanation purpose. You don't have to write this in the GATE exam. You can directly write. Okay, this equation you can write directly, and then you can simplify. This equation you can simplify. Your final answer will be A bar CD or A, B, C bar. Okay, is this clear? Very simple. If you want, you can create K-map also. Okay, but this is best way. Okay, because this is a small expression. You can see this expression that is given to you. This is a small expression. So the best way is simplification. Of course, if you want, you can create a K-map also. 4 variable K-map you can create. You can create a 4 variable K-map, A, B, C, D. 4 variable K-map you can create, and then you can solve. Okay, but that will take some time. 4 variable K-map, if you create, that will take some time. So what you can do, the best way is you just do this simplification. This simplification will take less time. Okay, or you can eliminate the options. Or what you can do, once you have this equation you have y equal to this expression. Once you have this expression, you can eliminate the options. Okay, some options you can eliminate. Anyway, the answer will be option C. Now let's move on. Now let's solve this question. This is GATE Electronics 2022 question. Now in this question, a multiplexer is given to you. You can see, consider the 2-bit multiplexer. This multiplexer is given to you where you have 2 select lines. Okay, this is a 4x1 multiplexer. Now, for output to be exclusive OR of C, D, the values of A0, A1, A2, A3, what they should be. Remember, the question is saying that output must be C XOR D. Output must be C XOR D. Then what should be these inputs? What should be these inputs? So that is quite simple. You can see that is quite simple, because this we want XOR. Output should be XOR. So you can see these inputs you can see I0, I1, I2, I3, these input data lines, these should be 0, 1, 1, 0. Okay, so your answer will be 0, 1, 1, 0. That will be C. So your answer will be option C. Okay, remember what is happening here. Let me tell you. See, these are the select lines. On the select lines, S1, S0, these are your select lines. This S1 means this is MSB, and this S0, that means this is LSB. Okay, on MSB, this is the select line, MSB. On MSB, this variable C is connected. On LSB, this variable D is connected. Okay, and this is your output. This is your output. Now you can see when both are 0, then what will be the output? Tell me. When both are 0, these two select line, if you apply 0, 0, if you make both of them 0, 0, okay, means C0, D0, then in this situation, remember, this I0 will go to the output. Okay, in this situation, this I0, that will go to the output. So your output, that will be, your output will be I0. That means A0. Okay, your output will be A0. Your output will be A0. Okay, when you apply 0, 1, when you make S1 0 and S0 1, when you make C0 D1, in this situation, remember, this will go to the output. Okay, this I1 will go to the output. Your output will be equal to I1, and that is same as A1. That is same as A1. Next, you can see when you apply 1, 0, in this situation, remember, on the select lines, if you apply 1, 0, then this I2 will go to the output. Your output will be I2. That is same as A2. Okay. And finally, I can say, if you apply 1, 1, then in this situation, this I3 will go to the output, and I3, that is same as A3. Okay, I3 that is same as A3. So this is the idea. Now you can write the equation if you want. Okay, but remember, you want output that should be equal to exclusive OR. You want output to be XOR of C comma D. This is what you want. Okay, your truth table has C comma D. These are C comma D, and you want output C XOR D. This is what you want. So this is your truth table. You can see this is the truth table of XOR. Okay, so you can see that if you want XOR, then make it 0, 1, 1, 0. Yes or no? If you want XOR, so then you should make it 0, 1, 1, 0. Means you should make truth table of exclusive OR. This is what you want, XOR. So your answer will be option C. This is your answer. Okay, let's move on now. Let's solve this question. This is GATE Electronics 2023 question. In the circuit shown below, this multiplexer is given to you. This is 2x1 multiplexer that is given to you. On the select line, this variable Q is applied. You can see this variable Q, this is connected to the select line. P comma Q, these are the inputs. The logic function, what the function implemented by this circuit? The question is asking what the function that is implemented by this circuit. Remember, this symbol means ground. Okay, this is the ground symbol. This symbol is your ground symbol. What this ground symbol means? This ground symbol indicates logic 0. This ground symbol, this indicates logic 0. Okay, remember, yes or no? So this is the ground symbol that indicates logic 0. So you can simply say that your I0 is 0. Okay, your input I0, that is 0. Now you can easily see what will be your function that is implemented. So your function that will be implemented, you can see that will be when this select line is 0, when you take select line equal to 0, then output will be I0. Yes or no? Then output will be I0. When you take select line equal to 1, when you take this select line equal to 1, then output will be I1. Output will be I1. So from here you can see that your final answer is PQ. Okay, your final answer that is PQ. So your answer is option A. Okay, because please understand that you have this multiplexer. This is a 2x1 multiplexer that is given to you. On the select line, the variable Q is there. Okay, you have connected this variable Q to the select line. Now you can see when this Q is 0, then output will be I0, that is same as 0. When this Q is 1, then output will be same as I1, that is P. From this compact truth table, this is compact truth table. From this compact truth table, you can create Y that is equal to Q bar 0 or QP. So finally your answer will be PQ. Okay, so the answer is option A. Now let's move on. Now let's solve this question. This is GATE Electronics 2010 question. A multiplexer is given to you. This is a 4x1 multiplexer. There are two select lines. You can see this variable A that is connected to MSB and this variable B that is connected to LSB. Okay, this function FABCD that is given to you. The question is asking what is the function that is implemented by this multiplexer. Okay, this multiplexer is implementing which function? Yes or no? So this is the question. The Boolean function that is realized. What is the Boolean function that is realized by this circuit? This is what the question is asking. And you can see in the options, you can see this function is given to you as summation of minterms. Okay, in the canonical SOP form, you can see all the options. These are in the format of canonical SOP, or you can say summation of minterms. All the options, these are in terms of summation of minterms. Okay, so let's solve it. So let's write the equation for F. Let's write the equation for F, that is A, B, C, D. This is the order of variables. This is the order of variables. Remember, this is the order. This is the order of variables. F, A, B, C, D. This is the order of variables. Because remember, tell me one thing, why this order is given to you? This order, does it matter? Please tell me one thing. This order, does it matter? A, B, C, D. This order, does it matter? This order, does it matter? This order matters. Why? This order matters. Because whenever you use this notation, this small m notation, see, this order matters. Whenever we use this small m notation, yes or no, this mi notation, this mi notation. So remember, this order matters. This variable order, this order matters whenever we use this small mi notation or capital Mi notation. Okay, this small mi notation, you can see whenever you use this small mi notation, then in this situation this order matters. Okay, anyway, so let's write the equation for f. Tell me what is f, let me know. F is equal to, you can see these are the variables a b. When both are 0, a0 b0, when both are 0, in this situation what the function value? When both are 0, then this function will be equal to I0. Yes or no? When both are 0, A, B, when both are 0, then this function value will be equal to I0. I0 is same as C. So you can see in this situation, function value will be C. Next, when A is 0, B is 1. In this situation, what the function value? When A is 0, B is 1. When A is 0, B is 1, then the function value will be I1, that is same as D. That is same as D. Okay, yes or no? That is same as D. Or when A is 1, B is 0, then what the function value? When A is 0, when A is 1, B is 0, A is 1, B is 0, then your function value will be I2. What is I2? What is I2? That is C bar. Yes or no? I2, you can check. You can check I2, that is C bar. Okay, so in this situation, you have C bar. Or finally, when AB, in this situation, what is the function value? What is the function value when you have both 1, 1? When A is 1, B is 1. When both are 1, 1, then the function value will be I3. And that is same as, what that? I3, that is same as, you can see C bar D bar. You can see C bar D bar. Yes or no? There is an AND gate here. So you can see here, you can easily see I3, that is equal to C bar D bar. Because there is a bubble here. This bubble simply means C bar. Okay, this bubble means C bar. And this bubble means D bar. And finally, you have AND gate. So there is C bar D bar. So your I3, that is equal to C bar D bar. Okay. So here I can say C bar D bar. Now you can easily write what are the minterms. Yes or no? So remember your function, that is equal to the order of variables that you already have, that is A, B, C, D. This is the order of variables. This is the order of variables. Now the function that you have, that is A bar, B bar, C, or A bar, B, D, or A, B bar, C bar, or A, B, C bar, D bar. Okay. Now let me tell you how to write the summation of minterms. If you have this expression, once you have this expression, this SOP expression is given to you. Remember, this is SOP expression. Once you have SOP expression, you can easily write the summation of minterms. Now from this SOP expression, how to write summation of minterms, how to find the minterms. Okay, basically we want to write the summation of minterms. This is how to write. Okay, the best way, let me tell you the best way. See, here what you can do, notice this is the order A, B, C, D. Remember, this is the order. Remember the order. Remember the order of variable, that is A, B, C, D. So here you can notice, in a minterm, all the variables must be there. Agree with me? In a minterm, all the variables must be there. Yes or no? See, from the SOP expression, we want sum of minterms. We want sum of minterms. We want summation of minterms. So tell me, in a minterm, all the variables must be there. Agree? What is a minterm? Minterm is a product term containing all the variables. Yes or no? Minterm, that is a product term containing all variables. Yes, correct. That is a product term containing all variables. Containing all variables. Okay, yes. So in a minterm, all the variables must be there. Remember this point. What is a minterm? What is a minterm? Minterm is a product term containing all variables. Okay, this is a product term. You can see this is a product term. This is important, that this is a product term containing all variables. Containing all variables. All variables. Okay. Containing all variables exactly once. containing all variables exactly once in complemented or uncomplemented form. In complemented or uncomplemented form. In complemented or uncomplemented form. So this is the definition of minterm. Now you can easily see that this is a product term containing all variables. Okay, you must have all the variables. Do you have all the variables here? Tell me. Do you have all the variables here? Please tell me. See, this is a product term. Notice this is a product term. Notice this is a product term. But do you have all the variables? This is a product term, but this is not a min term. But this is not a min term because why this is not a min term? Why this is not a min term? Tell me. Why this is not a min term? Because variable D missing. Yes or no? Variable D is missing. Okay, yes or no? Variable D is missing in this. So you can see variable D is missing. What about this one? This is a product term. This is min term also. What about this one? This is a product term. This is a product term. And this is a min term also. This is a min term also. You can see all the variables are there. This is a product term. This is min term also. You can see all the variables are there. Okay. Is this clear? Similarly, this is a product term, but this is not a min term. This is a product term, but this is not a min term. So let's make it min term. Let's make it min term. So you can see here, you have A bar, B bar, C, but you don't have D. But you don't have D. Okay, so tell me, because D is missing, so how many min terms you can create from this product term? From this product term, how many min terms you can create? This product term is given to you. From this min term, from this product term, how many min terms you can create? Remember, variable D is missing. So either you can have D bar or you can have D. Okay. Yes or no? Either you can have D bar or you can have D. What is this min term? This is your min term number what? Tell me. This is 0, 0, 1, 0. This is min term 2. This is min term 3. Yes or no? This is min term 3. So from here you got min term 2, min term 3. Now let's focus on this. Let's focus on this. Here what you have? Here you have A bar, B. Remember C is missing. And remember the order. Remember the order. Order is ABCD. Order is ABCD. Remember the order. Order is ABCD. Here you can see in this product term, this variable C is missing. This is a product term, but this is not a min term. This is a product term. This is product of literals. This is a product term, but this is not a min term. Why this is not a min term? Because variable C is missing. Yes or no? This is a product term, but this is not a min term because variable C is missing. So tell me, from this product term, how many min terms you can get? This product term is expressing how many min terms? Remember, this product term is expressing 2 min terms because variable C is missing. So either that C is complemented or that C is uncomplemented. So remember, this product term is expressing 2 min terms. And tell me, what is this min term? This is your min term 0, 1, 0, 1. This is your min term 5. And what is this min term? 0, 1, 1, 1. That is your min term 7. Yes or no? Very simple. You got these. Now you tell me, from this, which min terms you will get? From this. Tell me, is this a product term? Yes, this is a product term because this is product of literals. You can see this is a literal. So you can see this is a product term because this is product of literals. But this is not a min term because variable D is missing. Again, you can see variable D is missing. Now tell me, this product term can express how many min terms? This product term is expressing 2 min terms, okay, because variable D is missing. So either that variable D is complemented or that variable D is not complemented. Okay, either that is complemented or that is not complemented. So tell me, what is this min term? This min term, this is your min term number 8. And what is this min term? That is 1, 0, 0, 1. That is your min term number 9. And finally, this is already a min term. This is already a min term. Which min term? This is your 1, 1, 0, 0. That is your min term 12. Yes or no? This is already a min term because all the variables are there. This is a product term. In this, you have all the variables, and this is a product term containing all the variables. So I can say This is already a minterm, that is minterm number 12. So tell me, from this function, for this function, how many minterms you have? How can I write summation of minterms? This function I want to write as summation of minterms. Summation of minterms. So that will be very simple. That is 2, 3, 5, 7, 8, 9, 12. So the answer will be 2, 3, 5, 7, 8, 9, 12. Okay, your answer is 2, 3, 5, 7, 8, 9, 12. So the answer is option D. Yes or no? The answer will be option D. Option D is the answer. Is this clear? Please tell me, did you understand? Very simple question. A multiplexer is given to you. The question is asking what the function that is implemented. What the function that is implemented by this multiplexer. So what you can do, you can write the expression for this function. For this function, you can write the expression very easily. So this expression you will get. From this expression, you can find what are the minterms. Okay. From this expression, remember this expression you have. From this expression, you can find the summation of minterms for this function. For this function, the summation of minterms will be 2, 3, 5, 7, 8, 9, 12. So your answer, the final answer, that will be option D. That is your final answer. Okay. Is this clear? Please tell me. Is this clear? Very simple question. Now tell me, in the GATE exam, how can you solve it? In the GATE exam, if you want to solve it, you can eliminate the options also. Yes or no? See, in the GATE exam, you can eliminate the options also. In GATE exam, you don't have to do the complete analysis. Please understand, in the GATE exam, you don't have to do the complete analysis. In the GATE exam, you can eliminate the options. Okay, in the GATE exam, you can eliminate options. Just eliminate options. So tell me, how can you eliminate options? How can you eliminate options? Tell me, anyone, how can you eliminate options? You can easily see that when A is 0, B is 0, then the output will be what? You can easily see when A is 0, B is 0, then output will be C. Yes or no? When A is 0, B is 0, then the output will be C. Agree? So you can see that from here, which minterms you got? See, when you have A 0, B 0, okay, A, B, when both are 0, 0, then your output that will be equal to C. Okay, so I can say from this A bar, B bar, C, how many minterms you got? You got 2 minterms. Okay, you got 2 minterms, remember, because this is already like 0, 0, 1. Okay, one position is remaining. 0, 0, 1. One position is remaining. This variable D is remaining. Okay, you can see this variable D that is remaining. This variable D that is remaining. So you can put it 0 or you can put it 1. So finally, I can say you got minterm 2, minterm 3. If you got minterm 2, minterm 3, which options are gone? Which options are gone? You got minterm 2, minterm 3. You got minterm 2, minterm 3. You got. So option A gone. Option A is gone. Yes or no? Okay. You can see option C is also gone because you can never get minterm 1. Okay. Yes or no? You can never get minterm 1. So option A is gone. Option C is gone. So from here, option AC eliminated. Okay. From here, option AC eliminated. Yes or no? Option AC are eliminated. Okay. Now you will focus on what? Now you will focus on what? See, now option B, D are remaining. Option B, D are remaining. You focus on 9. Let's focus on 9, or maybe you can focus on 13. That is your choice. Let's focus on 9. Let us focus on 9. Is 9 a minterm? Okay. Remember, option B, D are remaining. Option B, comma D, these are remaining. So let's focus on minterm 9. Okay, let's focus on minterm 9. That means 1, 0, 0, 1. That means A, B bar, C bar, D. Is this a minterm of the function? Just check it. When you have A, B bar, means when A is 1 and B is 0, then what is the function value? When A is 1, B is 0, what is the function value? When A is 1, B is 0. When A is 1, B is 0, then the function value that is equal to C bar. That is equal to C bar. Okay, that is equal to C bar. So from here, which minterms you got? From here, which minterms you got? You got minterm 9, minterm 10. Yes or no? From here you got, sorry, minterm 9 comma minterm 8. From here you got minterm 9 comma minterm 8. You got minterm 8, minterm 9. So that's it. So that's it. That's it. So minterm 9 is a minterm. I can say yes or no. 9 is a minterm for this function. So finally I can say answer will be option D. Option B is also gone. Okay, so from here option B eliminated. From here option B gone. So your answer will be option D. Is this clear? Please tell me. Is this understood? Remember in the GATE exam, in those 3 hours, when you are in the GATE exam, when you are sitting in the GATE exam, when you are attempting the GATE paper, okay, in those 3 hours, you don't have to do the complete analysis. You can simply do the option elimination. Okay. Remember in those 3 hours, you should solve the question as quickly as possible. Okay. You should solve this question as quickly as possible. Is this clear? So very simple point. So remember, so either you can eliminate the options like this. I have done it. Okay. Did you understand this option elimination method? This option elimination method, did you understand how I am eliminating the options? You can eliminate the options very easily. Okay. Yes or no? Is this clear? Please tell me. So a student is asking how you got M8. How you got M8? See, in this, look at this multiplexer. In this multiplexer, when you have A1, B0, when you have A1, B0, then what your output will be? Tell me. When you have A1, B0, remember A is connected to select line S1. This B is connected to select line S0. So when you have A1 and B0, then your function value, that will be C bar. Okay, that will be C bar. Yes or no? Now you can see, because of this in your F, what will happen? Because of this, remember, because of this in F, you will get this expression A, B bar, C bar. Okay, yes or no? Something, something, something. Agree? Is this clear? Okay, because of this row, you will get this in your function, in the expression of function. Okay, yes or no? Now, this is a product term. This is a product term, but this is not a min term. See, this is a product term. This is a product term, but this is not a min term. Which variable is missing? In min term, all the variables must be there. In min term, all the variables must be there. Variable D missing. Yes or no? Variable D is missing. Here, variable D is missing. Because variable D is missing, you can see, look at this. A, B bar, C bar. Here you can notice variable D is missing. Please understand, this is a product term because this is a product of literals. Okay, this is a product of literals. This is a product of literals. You can see, this is a literal, this is a literal, this is a literal. So this is a product term, this is a product of literals. Here you can notice this is not a min term. Why this is not a min term? This is a product term, but this is not a min term because variable D missing. Because variable D is missing. Okay, that is missing. So that is missing. So that is the reason this is not a min term. But notice one thing. This min term expresses two min terms. Okay, remember, sorry, this product term is a combination of two min terms. Okay, this is a combination of, please understand, this is a combination of this product term, this is a product term. You can see this is a product term. This product term is a combination of two min terms. Two min terms because variable D is missing, right? Yes or no? So this is a combination of two min terms because you can see the variable D is missing. One is A bar, B bar, C bar. Variable D is missing. Variable D is missing. So either you can put it complemented form or you can put it in uncomplemented form. You can notice if you do the OR of these two, you will get A, B bar, C bar. You can notice A, B bar, C bar, D bar, or A, B bar, C bar, D. You will get A, B bar, C bar. Is this clear? Okay. So tell me, did you clearly understand what is happening here? See, this product term is given to you. Now I'm saying that in this product term, the variable D is missing. The variable D that is missing. So what you can do? Either that variable can be present in the complemented form or that variable can be present in uncomplemented form. You can notice that if you do the OR of these two, if you combine these two, you will get this product term. If you combine these two. Okay, so this is what I'm saying, that this product term is expressing two minterms. And this minterm, this is your minterm 8, this is your minterm 9. Okay, yes or no? So this is what I'm saying, that this expresses minterm 8 comma minterm 9. Okay, this will express minterm 8 minterm 9. So because of minterm 8 minterm 9, this is expressing minterm 8 minterm 9. So because of that, option B is eliminated. Okay, this option B, this is gone. Option B, that is gone. Is this clear? So like this, you can eliminate option B. And similarly, you can eliminate option A, comma, option C. Those also you can eliminate. You can easily see here. Okay. You can see that using this combination, when A is 0, B is 0, then the function value must be C. From this combination, you can eliminate option A, comma, C. Option A, C are gone. Okay. So finally, answer will be option D. So this is option elimination method. Either you can apply this method in the GATE exam, or you can apply the correct way, the analytical way. You can see here, this is the analytical way. Okay, you can write the expression for f. This is the expression for f. Then from this expression, you can write this function as sum of minterms. From this expression, you can find canonical SOP for this function. Okay, finally, you will get answer option D. Now let's move on. Let's solve this question. This is GATE Electronics 2018 question. You can see multiplexers are given to you. 4x1 multiplexer, 4x1 multiplexer, 2 multiplexers are given to you. And the question is asking a 4 variable Boolean function is implemented. You can see this is the 4 variable Boolean function that is implemented by this circuit. Okay. Now the question is asking the minimized expression for this function. For this function, what is the minimized expression? Okay, yes. So very simple. Now you tell me what this symbol means. What this symbol means. This is your ground symbol. This is your ground symbol. Okay, this ground symbol indicates, remember this is your ground symbol, and this ground symbol indicates logic 0. Logic 0. Okay, so this ground symbol indicates logic 0. Okay, similarly, this ground symbol indicates logic 0. You can say that this is logic 0. Okay, and this VCC, this indicates logic 1. Okay, this VCC indicates logic 1. Voltage indicates high voltage. Okay, remember, high voltage, this indicates high voltage comparing to ground. Is this clear? So remember this VCC, this indicates high voltage with respect to ground, Okay, so this is the point. This VCC, this indicates high voltage with respect to ground. So this VCC indicates 1. Okay, and this ground indicates 0. So finally what you have? You have I3 is equal to 0. Yes or no? Finally, you have I3 is equal to 0. You can see I0 is equal to 0. You can see I1 is equal to 1 and I2 is equal to 1. Correct? Okay, I1, 1 and I2, 1. Is this clear? So you can see. Now tell me, what will be the output? Let me know. What will be the output? So finally here, this, okay, here, let's call it F1. So tell me what F1 will be. I'm asking, let's call it F1. So what F1 will be? Tell me. This F1, you can see 0, 1, 1, 0. Okay, you can notice here 0, 1, 1, 0. Please notice 0, 1, 1, 0, 0, 1, 1, 0. Okay, so this is XOR. Yes or no? 0, 1, 1, 0. This is XOR. Correct? 0, 1, 1, 0. This is XOR. You can easily see. You can easily see this is your XOR. I can say this is XOR. Okay, XOR of U, V. XOR of U, V. because on the select line you have UV. On the select line you have UV. Okay, I hope this point is clear. On the select line you have UV, because remember, okay, let's focus on F1. Let's focus on F1. On the select line you have UV. Okay, this S1 on the MSB, this means MSB. So on the MSB select line you have U, and on the LSB select line you have V. Okay, and you can notice, you can easily see that for these combinations your function value is 0 1 1 0. So your function is nothing but XOR. Your function is U XOR V. This is your function. Yes or no? So we got F1. F1 is U XOR V. Remember, we got U XOR V. This is what we got here. Okay. And remember, I2 is 0. I3, that is also 0. So finally, what is your F? Finally, what is your F? F is U XOR V. U XOR V. Okay. See, finally, let me tell you what is F. Now let's see what is F. F is equal to, when both are 0, in this multiplexer, focus on this multiplexer. When both are 0, W bar, X bar, when both are 0, what will be output? Tell me. When both are 0 on the select line, these are the select line. On select line, if you put 0 0, if you make both of them 0 0, W bar, X bar, then output will be I0. Then output will be I0, and I0 means U XOR V. Or when W is 0, X is 1, then output will be I1. When W is 0, X is 1, then output will be I1. I1 is also U XOR V. Yes or no? Is this clear? So finally, what you got? Finally, you got F is equal to W bar X bar U XOR V. Okay, U XOR V, or W bar X U XOR V. Okay, so this is what you got. Is this clear? Please tell me. Now what you can do, for a moment, assume that this U XOR V, assume, for example, let's call it P. Let's call it P. Okay, let's call it P. If you call it P, then tell me what you will get. It's like W bar X bar P or W bar XP. So what you can do, you can take W bar P out. You can take W bar P out. Yes or no? Okay, let's call it P. This U XOR V, let's call it P. So now you can take W bar P out. So inside you will get, that is equal to W bar P. So your final answer is W bar P. Okay, so remember, your final answer will be W bar P, and that is same as W bar U XOR V. Okay, you can open this U XOR V. You will get U bar V or UV bar. So your answer will be W bar U bar V or UV bar. So what is your final answer? Tell me. What is your final answer? You can see your final answer is option C. Your final answer, that is option C. Yes or no? Is this clear? So finally, I am saying that F is equal to W bar in the bracket U XOR V. Okay, if you open this U XOR V, you will get W bar, U bar V or UV bar. Okay, so your answer is option C. Now you tell me one thing. Look at option A. This is not correct, right? This is not same as F. See, look at option A. That is not same as F. Option A, that is not same as F. Yes or no? That is different from F. Okay, because what is option A? Option A is U XOR V W bar. Yes or no? U XOR V W bar. This is option A. So this is not same as F. Okay. Similarly, option B, that is also not same as F. But what about option D? If you simplify option D, what are you getting? If you simplify option D, you are getting, if you simplify option D, that is same as F. Yes or no? Can you notice? If you simplify option D, then, so this is same as F. Agree with me? What I'm saying? Please notice what I'm saying. I'm saying option D. I'm saying Option C is also equivalent to F. Option D is also equivalent to F. Both are same as F. Okay, both are same as F. Is this clear? But remember, the question is asking minimized expression. The question is asking minimized expression. Okay, the question is asking minimized expression. So option C, if you look at option C, this option C is like this. In this option C, you have U V bar or U bar V W bar. In option D, what you have? In option D, you have U V bar or U bar V and W bar X bar or W bar X. So here, if you notice one thing, then the question is asking minimized expression. Minimized expression. So answer will be option C. Yes or no? Is this clear? Please tell me. Is this clear? The question is asking minimized expression. Okay, question asks for minimized expression. Okay, the question is asking for minimized expression. So that is the reason answer is option C. Is this clear? Please tell me. Is this clear? That answer is option C only. Okay. The answer is option C only because the question is asking for minimized expression. So answer will not be option D. Answer will not be option D because of this minimized. Okay. But remember, option A, option B, these are not even function F. Option A, that is not even equal to F. Option A, option B, these are not expressing function F. These are not same as function F. But option C, option D, these are same as function F. But you can see the question is asking for minimized expression. So your answer will be option C. Now you tell me one thing, one very interesting thing I want to ask you. The question is asking for minimized expression. Is this minimized SOP? Tell me. Forget about everything else. You just focus on this and tell me, is this SOP? Is this SOP? Is this SOP? Is this sum of product? Is this sum of product terms? Is this sum of product terms? So you can see this is not SOP. This is not sum of product terms. This is not sum of product terms. This is not a sum of product terms, right? Yes or no? You can see this is not SOP form. This is not SOP form. And what about POS? Is this product of some terms? Is this product of some terms? This is not product of sum. This is not product of sum. Okay, so please understand that this is minimized expression. This is a minimized expression. This is minimized expression, but not minimized SOP or minimized POS. But not minimized SOP or minimized POS. Is this clear? Please tell me. Let me know. So remember, this is minimized expression, but this is not minimized SOP or minimized POS. Okay. So if the question asks you minimized SOP, you give minimized SOP. If the question asks you minimized POS, you give minimized POS. Okay. But here the question is asking minimized expression. Okay. Minimized expression. So you can see this expression is given in the options. This is not SOP form. This is not POS form, but this is minimized expression. So this is a note I want to tell you, that minimized expression, that need not be minimized SOP or minimized POS. Yes or no? Minimized expression of F. Minimized expression of F. Okay. May not be same as minimized SOP or minimized POS. Yes or no? May not be same as minimized SOP of F or minimized POS of F. Is this clear? Please tell me, did you understand? Minimized SOP of F, minimized POS of F. So remember, minimized expression may not be same as minimized SOP or minimized POS. Is this understood? Please tell me. Let me know. Is this understood? And what K-map will give you? What K-map will give you? Tell me. What K-map gives you? What K-map gives you? K-map gives us K-map gives us minimized SOP or minimized POS. Yes or no? Remember, this K-map gives us minimized SOP or minimized POS. Okay, so remember, when you apply K-map, then remember, you will get minimized SOP, or if you want, you can get minimized POS. But remember, minimized expression may not be same as minimized SOP or minimized POS. Okay, so this is a nice question. This is a beautiful question. The reason is simple, that in this question, if you look at the options, two options are matching F. Okay, you can see option C, option D, they are matching F. Option C, option D, they are both same as F. Option C is also same as F. Option D is also same as F. But the question is asking for minimized expression. So the answer will be option C. Answer will not be option D. And also remember, this option C, that is not minimized SOP, that is not minimized POS. Okay. So is this clear? Please tell me. All these doubts, are they clear? Please tell me. A student is asking, why it is not minimized SOP? X is not there, that's why. No. See, this is not minimized SOP. This is not even SOP. Forget about minimized. This is not even SOP. Look at option C. Look at option C. This is not even SOP. See, look at option C. Option C is given to you UV bar or U bar V W bar. You tell me, is this a sum of product? You look at this and tell me, is this sum of product? Is it sum of product terms? Is it sum of product terms? Tell me, is it sum of product terms? Means, remember, what is sum of product terms? Sum of product terms. That means sum of product terms means you have sum, and here you have product term, here you have product term, and so on. Yes or no? Here you have a product term. Here you have a product term. Here you have a product term. Here you have product term. So is this SOP? Please tell me. No, this given expression I'm asking. This given expression you tell me. Don't modify it. Is this given expression? I'm asking this given expression. Is this SOP? Don't modify. For example, okay, see, for example, if I ask you, if I give you a function f equal to a, b or b bar, a, b or b bar, if I give you this, now you tell me, is this, see, you already know that this same f, I can also write like this. I can also write like this, but these are different forms. Please understand. This same f, I can also write like this. This same f, I can also write like this. Is this clear? Tell me. This same f, I can also write like this. So these are different forms. Please understand. All these are different forms. These are different forms. Different forms of f. Okay, these are different forms of f. For example, you can see this is SOP also, this is POS also. This is SOP also, this is POS also. For example, this is SOP, this is not POS. Yes or no? For example, this is, what about this? This is product of some terms. Yes or no? This is POS, but this is not SOP. What about this? This is SOP, but this is not POS. Is this clear? Please tell me. Let me know. And let me write like this. Let me also write like this. B or AB or B bar. The same function. You can see this is the same function. Yes or no? You can see. But now you can see this is not SOP, this is not POS. This is not SOP, this is not POS. Is this clear? Please tell me. So the same function can have different forms. These are different forms of the same function. Okay. Is this clear? Please tell me. Let me know. So now you can see this option C. This is not SOP, this is not POS. This is not SOP, this is not POS. Is this clear? So look at option C. This is not SOP form. This is not in SOP form. This is not in POS form. Okay, understood? Please tell me, did you understand? So very simple. So remember, this question is asking for minimized expression. So answer will be option C. But I want to tell you that minimized expression may not be same as minimized SOP or minimized POS. This note, did you understand? Please tell me. This note, minimized expression, that may not be same as minimized SOP or minimized POS. Okay, is this understood? So remember K-map. K-map will give you minimized SOP. K-map will give you minimized POS. Okay, but remember, minimized expression can be anything. Minimized expression can be anything. Now let's move on. Now let's solve this question. This is GATE Electronics 2014 question. So let's solve it. You can see multiplexers are given to you. 2 multiplexers are given to you. 4x1 multiplexer, 4x1 multiplexer. And the question is asking what the output F. This output F we need to find out. Okay. Now let's see. This VCC, what this symbol means? This VCC, this symbol means 1. This symbol means 1. And what this grounded symbol means? And what this ground symbol means? This ground symbol means 0. This means 0. Okay. So remember, this ground symbol means 0 and this VCC symbol, that means logic 1. That means 1. Okay. So you tell me here, you tell me, let's call it F1. What is F1? Please tell me. What is F1? You can see I0 is 0. Okay, because this ground symbol, this means 0. This means 0. Okay, I1 is 1, I2 is 1, I3 is 0. So can you notice this is your XOR? Yes or no? This is your XOR. You can see WX. You can see WX. And so you can see F1, that is same as Q. F1, that is same as Q. Okay. So what is your Q? You can see when both are 0, when WX both are 0, when WX both are 0, in this situation, you can see your Q, that is equal to I0, that is 0. Okay. When you have 0, 1, when W is 0, X is 1, then your output will be, your Q will be I1, that is same as 1. Okay. When you have I0, then I2, then Q will be I2. I2 is 1. And when both are 1, on the select line, if you put 1, 1, then your output will be I3, that is same as 0. So can you notice this? If you look at this, this is your XOR. So Q is equal to W XOR X. So this is what you got. Okay, this is your XOR. You can easily see here also, you can see that this is your XOR. This is the XOR. So you got Q equal to W XOR X. Okay, this is what you got. So remember Q, that is equal to Q, this Q is equal to W XOR X. W XOR X. Okay. Now let's see. You can see this I2 is 0. I3 is also 0 because this ground symbol, this symbol means 0. This symbol means 0. Okay. And you can see I0, that is Q. I0 is Q. I1 is Q. I0, I1, these are Q. Okay. So tell me finally what is this function F? Finally, what is this function F? Let me know. Finally, what is this function F? You can see when both are 0, y 0, z is 0. When on the select line, if you put 0, 0, then your output will be I0. Then your output will be, I can say, your output will be W XOR X. Okay. Or when you put Y0, Z1, when you put Y0, Z1, okay, when you put Y0, Z1 on the select line, if you put 0, 1, then your output will be I1. Then your output will be I1. And I1 is same as W XOR X. So what is your function finally? What is your function finally? So if you look at your function, that is finally, that is Y bar, Z bar, W XOR X, or Y bar, Z, W XOR X. Okay, is this clear? Please tell me. Now what you can do for a moment, just assume this is P. Just assume this is P. Okay, let's assume this is P. Let's assume this is P. Okay, let's assume this is P. So what you have? You have Y bar Z bar P or Y bar Z P. So you can take this Y bar P out. Okay, you can apply the distributive property. You can take this Y bar P out. So inside you will get Z bar or Z. That is same as Y bar P. Okay, so remember your F, that will be same as Y bar P. Y bar, and what is P? P means W XOR X. Okay, W XOR X. So let's see. Any option, is it matching? Is any option matching? So you can see. Okay, now you can further simplify. You can write it Y bar. You can write it W bar X or WX bar. Okay, if you further simplify, you will get Y bar W bar X or Y bar W X bar. Y bar W bar X. Okay, Y bar W bar X or WX bar Y bar. So I think answer will be option C. You can check it. You can check it. Okay. So the answer, that is option C, right? Y bar W bar X. Yes. So the answer will be option C. You can check it. In this option C, remember this is X bar Y bar. Okay. Please understand, this is your W X bar Y bar or W bar X Y bar. Okay. And this is your answer. You can easily see. This is the answer that we got. Correct? Is this clear? You can see. W bar Y bar X or W X bar Y bar. Yes. So the answer will be option C for this question. Okay. So this is another very simple question. You can solve it easily. You can solve it. Now let's move on. Now let's solve this question. This is GATE Electronics 2014 question. Now, in this question, two multiplexers are given to you. This circuit is given to you. This combinational circuit, this logic circuit is given to you. The question is asking what is this function F. You can see which of the following function is realized by this circuit. Okay, what is the function that is implemented by this circuit? So let's see. First, you tell me for the first multiplexer, what is the output? What is this output? You tell me here. Means for the first multiplexer, what is the output of the first multiplexer? See, you can see in this first multiplexer, you can see on the select line, if you put 0, then what your output will be? On the select line, if you put 0, what your output will be? Tell me. On the select line is S1. If you put 0, then your output will be I0. That is same as W. On the select line, if you put 1, then your output will be I1. That is W bar. Okay. So if you see this equation, you will get that when you have S1 0, then output is W. When S1 is 1, then output is W bar. That is your XOR. S1 XOR W. Okay, yes or no? S1 XOR W. So you got this output. Here you got S1 XOR W. This is what you got. Now you tell me, what will be F? Okay, let's see. Let's call it something like P. Let's call it P. Okay, let's call it P. For a moment, let's call it P. So what will be F? What will be F? You can see when S2 is 0. When S2 is 0 means S2 bar. Then what will be F? Tell me. When S2 is 0. When S2 is 0 means S2 bar. Then F will be. Tell me. Then F will be P. Yes or no? F will be P because here you have P. I can say here you have P. Okay, here you have P. So you can easily see when S2 is 0, then F1 will be, then this F will be I0, means F will be P. And when S2 is 1, then F will be P bar. Then F will be P bar. So what you got? You got S2 XOR P. S2 XOR P. Yes or no? So remember, finally, I can say your F is equal to, so remember your F, this function F, this is equal to S2 XOR P. And what is P? P is already S1 XOR W. Okay, so finally your answer, that is S2 XOR S1 XOR W. So your answer will be option D. Yes or no? Answer will be option D. Because remember, XOR is commutative and associative. Okay, XOR is commutative and associative. We already know this XOR. This XOR is commutative and associative. This is commutative also, and this is associative also. Okay, this is commutative and associative. So if you have this type of equation like A XOR B XOR C, if you have this type of equation, you can simply write it A XOR B XOR C. You can also write it B XOR A XOR C. You can also write it C XOR B XOR A. Okay, you can write it in any way you want. You can also write it C XOR A XOR B, because XOR is commutative and associative. So finally here answer will be option D. Okay, very simple question. Now let's move on. Now let's solve this question. This is GATE Electronics 2017 question. In this question, two multiplexers are given to you. You can see this is the circuit. This is the digital circuit. Combinational circuit is given to you. The question is asking what the function that is implemented. This function f. What the function that is implemented? This is what the question is asking. Now let's first see what the output of this first multiplexer. This first multiplexer. Let's call this output P. So tell me what is P? Let me know what is P. You can see when x is 0, this select line, on the select line if you put 0, means when x is 0, then this output will be equal to y. Yes or no? On the select line if you put 0, then output will be I0. I0 means y. Okay. On the select line if you put 1, then output will be 0. Then output will be 0. On the select line if you put 1, means if this x is equal to 1, then output will be I1. Output will be I1. I1 is 0. So here I can say P is equal to x bar y. Okay, so this P, that is x bar y. Now let's see what the equation for f. Let's see. You can see when z is 0, when you put this z equal to 0, then in this situation output will be P. Yes or no? In this situation output will be P. Correct? When z is 0, then this function f, that will be I0. I0 means P. Or when this z is 1, if you put this z equal to 1, then output will be I1. I1 means P bar. I1 means P bar. So finally what you have, you can write it. Okay, so your function f, that will be equal to, f will be equal to z bar P. P means x bar y. Or z P bar. Z P bar. What is P bar? You can apply the De Morgan law. Okay, you can apply the De Morgan law, that will be x or y bar. You can apply the De Morgan law, that will be x or y bar. Okay, because remember, if you have x bar y, okay, this is your P. So what will be P bar? P bar, that will be x bar y whole bar, that is same as x or y bar. Okay, using the De Morgan law, you can apply the De Morgan law. So finally here you have this function f equal to x bar y z bar or x z or y bar z. Okay, so you can see which option is matching. This is MCQ question. Only one option will be correct. Okay, only one option will be correct. You can check which option is matching. X bar, Y, Z bar, or XZ or Y bar Z. So the answer option B. Yes or no? Answer will be option B. Now let's move on now. Now let's solve this question. Let's solve this question. So now let's solve this question. This is GATE 2015 question. GATE Electrical 15. Okay, this is from the electrical. Okay, so you can see. So this is GATE Electrical 2015 question. A multiplexer is given to you. A Boolean function f, that is written as a product of max terms. You can see this function f, that is written, that is given as a product of max terms, is to be implemented by 8x1 multiplexer. This 8x1 multiplexer is given to you. You can see these are the select lines. This is your 8x1 multiplexer. So there will be 3 select line. Yes or no? This is your 8x1 max. So there are 3 select line. You can see this A is connected to MSB. This C is connected to LSB. Okay, and this is your multiplexer. The input ABC are connected to select line S2, S1, S0 respectively. Okay. Which of the following options gives the correct inputs to the pins 0, 1, 2, 3, 4, 5, 6, 7 in order. So this is quite simple question. You can see here. First of all, see, this is a 8 by 1 multiplexer. Okay, this is your 8 by 1 multiplexer, and your function has 4 variables. Yes or no? Your function has total 4 variables, and this 8 by 1 multiplexer is given to you. If you want to find on the input, on the data inputs, what should be the, I can say, what should be the correct inputs on these pins? Okay, so what you can do, you can create the truth table. You can create the truth table, you can create. So let's create the truth table for this function. So first of all, this function that is given to you, that is ABCD. This function is given to you as a product of max terms, as a product of max terms, that is 1, 5, 12, 15. Yes or no? As a product of max terms, this function is given to you. So tell me from here, what it means. Tell me. If you know that function is given as product of max terms, this is given as product of max terms. So it means function is 0 for these combinations. Yes or no? Okay, yes or no? For these combinations. So I can say, so for these combinations, remember, for combinations. So remember, for combinations 1, 5, 12, 15. 1, 5, 12, 15. For these combinations, okay, your function value, for these combinations, your function value is 0. Else function value is 1. Correct? Else function value will be 1. Now what you can do? You can just create the truth table. Okay, for this function, you can create the truth table. But remember, on the select line, you have 3 variables, A, B, C. So just keep A, B, C. Okay, just create a compact truth table. Just create a compact truth table. Okay, just create a compact truth table. What you can do? You can create a compact truth table ABC like this. Okay, and this is your function. So you can do 0, 0, 0. Tell me, when all are 0, what will be the function value? When all are 0, then what will be the function value? If you put all equal to 0, then what is going to be the function value? See, what you can do here, you can express f also. Okay, see, this f is given to you. That is given to you pi 1, 5, 12, 15. This is given to you. So you can open it. What you can do, you can open it. It's like max term 1 multiplied by max term 5 multiplied by max term 12 multiplied by max term 15. Tell me, what is max term 1? Let's see. What is max term 1? Remember, this is your function A, B, C, D. This is your function. This is the order A, B, C, D. So what is max term 1? Max term 1 means 0, 0, 0, 1. Okay, so what that will be? That will be A or B or C or D bar. Yes or no? That will be A or B or C or D bar. What will be max term 5? That will be 0, 1, 0, 1. That will be A or B bar or C or D bar. What will be max term 12? That will be 1, 1, 0, 0. That will be A bar or B bar or C or D. What will be max term 15? That will be A bar or B bar or C bar or D bar. Okay. Now you tell me, when all are 0, when you put ABC equal to 0, what you will get? Tell me, when you put ABC equal to 0, when you put ABC equal to 0, when you put them 0, then what your function value will be? When you put ABC equal to 0, in this you put ABC equal to 0, what your function value will be? Just put, okay, put ABC equal to 0. From here you will get D bar. Yes or no? If you put ABC equal to 0, from here you will get D bar. Okay. From here you will get 1. From here you will get 1. From here you will get 1. Finally you will get D bar. You can check it. See, you can check it, very simple. Remember, this function is given to you as a product of max terms. You can see. So this function is given to you as a product of max terms. I can say this f, this function f, that is equal to max term 1 and max term 5 and max term 12 and max term 15. Okay. Now you can see, if I put ABC equal to 0, what is your function value? You can put it in this expression. in this expression, put ABC equal to 0, A0, B0, C0, then you will get D bar. So remember, when you put A0, B0, C0, then you are basically getting D bar. Okay, you are getting D bar. Now, what about if you put 0, 0, 1? Then tell me, if you put 0, 0, 1, let me know. If you put A0, B0, C1, then this will be 1. You can see. Okay, then this will be 1. This also will be 1. This also will be 1. Okay, and this also will be 1. So finally, I can say this will be like 1. Yes or no? So the function value that will be 1. Yes or no? Is this clear? Please tell me. So now you can easily see that some options are gone. Okay, remember, very simple point. So far, what we got? So far, what we got that when ABC are 0, when you put all of them 0, then remember your function value should be D bar. Okay, your function value should be D bar, means this connection should be made to D bar. You should make it this connection to D bar. Similarly, when you put 0, 0, 1, then your function value should be 1. This connection should be made to 1. Okay, the question is asking what inputs you should put on these pins in this order. In this order. So the answer will start from D bar, then 1. Start from D bar, then go to 1. So the answer will be option B. All the remaining options are gone. Yes or no? All the remaining options are eliminated. All the remaining options, these are eliminated. This option eliminated, option eliminated, option eliminated. Please tell me, did you understand? So you don't have to solve the entire question. You do not have to solve the entire question. You can easily see that only from this combination, you can eliminate the options. Of course, if you want, you can solve. If you want, you can solve the entire question also. Okay. For example, tell me, if you put, okay, like for example, let me give you this combination 1, 0, 1. For this combination, what will be function value? Tell me, what will be function value if you put A1, B0, C1? If you put A1, B0, C1, then remember this will be 1, this will be 1, this will be 1, this will be 1. So I can say for here, the function value will be 1. Yes or no? For 1, 0, 1, remember, for this 1, 0, 1, the function value will be 1. So to this 5, you should connect 1. You can see. To this 5, you should connect 1. Tell me, what should we connect to 7? Tell me, what should we connect to 7? Let me know. What should we connect to 7? I'm asking, what should we connect to 7? So when you put A equal to 1, B equal to 1, C equal to 1, then what will happen? When you put A equal to 1, B equal to 1, C equal to 1, what will be function value? If you put A equal to 1, B equal to 1, C equal to 1, this will become 1, this will become 1, this will become 1, this will become D. Yes or this will become D bar. Correct? This will become D bar. So remember, this will become D bar. So I can say this connection should be to D bar. Okay, so you should end with D bar. You can easily see. So your answer, you can see option B. That is correct. Agree with me? So like this you can do. Please tell me, did you understand? Like this you can solve this question very easily. You can solve this question. Please tell me. Understood? Is this question clear to everyone? Let me know. Now let's move on. Now let's solve this question. This is GATE Electrical 2015 question. A multiplexer is given to you. This is a 4x1 multiplexer. The output F is A XOR B. This output must be A XOR B. Then what should be the inputs? I3, I2, I1, I0. What should be these inputs? So very simple. If you want XOR, then I0 must be 0, I1 must be 1, I2 must be 1, I3 must be 0. Now the question is asking this order. So that order will be 0, 1, 1, 0. So your answer will be 0, 1, 1, 0. Answer will be option B. Yes or no? Yes or no? See, very simple. You want XOR. What you want? You want XOR. Remember, this function you want XOR. This is what you want. This is what you want. Okay. And you can see on the select line, you have A comma B. On the select line, you have A comma B. A means S1. B means S0. Okay. Now you can see on the select line, if you put 0, 0, then your output will be, then your output F, that will be I0. If you put 0, 1, your output will be I1. If you put 1, 0, your output will be I2. If you put 1, 1, your output will be I3. But what you want A XOR B. You want A XOR B. So you want 0, 1, 1, 0. This is what you want. So your answer will be option B. That is 0, 1, 1, 0. Okay. So very simple question. Now let's move on. Now let's solve this question. This is GATE Electrical 2016 question. A multiplexer is given to you. Now let's solve it. Consider the following circuit which uses a 2x1 multiplexer. In the circuit, this is given to you. You can see on the select line, variable B is applied. You can see this Boolean variable B that is connected to select line S. The Boolean expression of the output in terms of A, B, what that will be? What that will be? You want F. You want F. Remember, on the select line, you have B. On the select line, you have B. This is on the select line. This is on the select line. So if you put B equal to 0, what output will be? If you put select line equal to 0, on the select line, if you give this input 0, then F will be I0. F output will be I0. And I0 is A bar. You can see I0 is A bar. This means A bar. Okay. And if you put B equal to 1, on the select line, if you give B equal to 1, then your output will be I1. That is same as A. So your equation will be what? F. What is your equation? You can see when B is 0, B bar, A bar. When B is 0, function value is A bar. When B is 1, function value is 1. So that is same as A XNOR B. Yes or no? That is A XNOR B. That is same as complement of XOR. That is same as complement of XOR. Yes or no? Complement of XOR. So your answer will be option D. Very simple question. Now let's move on. Let's solve this question. This is GATE Instrumentation 2022 question from the GATE Instrumentation exam. So in this question, a digital circuit is given to you. In this digital circuit, you have two multiplexer. You can see the question is asking what is the function that is implemented. Okay, in this digital circuit, what is this function F that is implemented? First, you tell me what is the output of this multiplexer, this first multiplexer. What is the output of this first multiplexer? You can see for the first multiplexer, on the select line, you have variable B. On the select line, you have variable B on the select line. Yes or no? So you can see, let's call it P. Let's call it P. So this P will be equal to what? You can see on the select line, you have variable B. So if you put B equal to 0, this output P will be I0. Okay. Remember, when you put on the select line, when you put 0, when you put B equal to 0, then output will be I0. I0 means 1. So when you put B bar, then output will be 1. Or when you put B equal to 1 on the select line, if you put 1, then output will be I1, that is 0. So finally, your P is nothing but B bar. This P, this is nothing but B bar. Okay, what is F? You can see F is, if you put A bar, means if you put A equal to 0, then this F will be equal to I0, that is 1. And when you put A equal to 1, then this F will be I1. Okay, so that will be A bar or A. What is I1? I1 is P. So that is A bar or A. P is B bar. Okay. Now you can, what you can do, see, this is a rule we have, alpha or alpha bar beta. What you can do, alpha or alpha bar beta. What you can do here, you can remove this alpha bar and you can simply write it alpha or beta. This is a rule. See, this is a very simple rule. If you have alpha or alpha bar beta, what you can do, you can apply the distributive property. Just apply the distributive property. Apply the distributive property. So you will get alpha or alpha bar and alpha or beta. Now this is nothing but 1. So finally you will get alpha or beta. This is the same thing I am saying. Okay. So you can do this. Remember, whenever you have alpha or alpha bar beta, you can remove this alpha bar. You will get alpha or beta. So here also the same thing. What you can do, A bar or AB bar. Okay. Remember, A bar or AB bar. The same thing. Remember, here this is your alpha. Here, this is your alpha bar. Yes or no? So finally, you can remove this A. Okay, so remember, when you have this equation, what you can do, you can remove this A. So finally, you will get A bar or B bar. This is what you are going to get. So finally, here we have A bar or B bar. That is same as AB whole bar. Using the De Morgan law, that is same as AB whole bar. So the answer will be option A. Yes or no? Answer will be option A. Now let's move on. Let's solve this question. This is GATE instrumentation 2021 question. Okay, GATE instrumentation 2021 question. In this question, you can notice 4x1 multiplexer is given to you. On the select line, your variable x, y. X is applied on MSB, Y is applied on LSB. Okay, the question is asking, see, a 4x1 multiplexer is given to you. There are two select line, and we are realizing this function f. Using this multiplexer, we are implementing this function f. This function f has total 4 variables. Those are x, y, z, w. These are the 4 variables. You can see that S0, S1, they denote the least significant bit and most significant bit of the select lines. Means this S0, this is the LSB. This S1, this is the MSB. Okay. And these are the input lines of the multiplexer. This I0 to I3, these are the input lines. So anyway, this multiplexer is given to you. Now the question is asking the canonical sum of product of this function f. For this function f, what is the canonical sum of product? So let's find out. So what you can do, you can write the expression for f, this f, for this function f. Remember, what is the order? Please tell me what is the order of the variables? Order of the variables in all the options, that is x, y, z, w. The order of the variables, that is x, y, z, w. This is the order of the variables. This is the order of the variables. Okay, now let's see. You can see when both are 0, means x bar, y bar, when both are 0, then what will be function value? When both are 0, when you put on the select line, if you put 0, 0, then what will be your function value? See your function value. When both are 0, x bar, y bar, then the function value is I0. Then function value will be I0. Then function value will be I0. I0 means z bar or w. Z bar or w. Yes or no? So remember, here you will have z bar or w. Okay. Or what you can do? Or what will happen? Tell me. If you have x bar y, means when you put 0, 1, then your output will be I1. What is I1? I1 is 0. Okay, I1 is 0. So this entire thing will be 0. Okay, this entire thing will become 0. I can say x bar y 0. Or what will happen? Tell me. X y bar. X y bar. Then your output will be I2. Then your output will be I2. What is I2? I2 is ZW. So that is x y bar ZW. Okay, you will get x y bar ZW. Or you can see when you put 1, 1 on the select line, if you put 1, 1, then your output will be I3. That is x y z. See, this is your I3. This is your I3. Okay, so you will get x y z w bar. X y z w bar. Okay, is this clear? Please tell me. So finally you have your function. You got your function. Now let's see what this function. See, this function you got, that is x bar y bar z bar or x bar y bar w. Okay, or x y bar z w or x y z w bar. Okay, so this is the function you got. Tell me, is this a minterm? We want sum of minterms. What we want? We want sum of minterms. We want sum of minterms. This is what we want. We want canonical SOP. Yes or no? We want canonical SOP. This means sum of minterms. This means sum of minterms. We want sum of minterms. Means we want canonical SOP. Okay. So you tell me, this is already a minterm because minterm is a product term containing all the variables. See, this is a product term. This is product of literals. Okay. This is a product term containing all the variables. So this is already a min term. This is your min term number what? Tell me. This is the order of the variables x, y, z, w. So this is min term number what? That is 1011. 1011. That is 11. Min term number 11. Yes or no? What about this one? This is also a min term. This is your min term number 14. 1110. Okay. But this is not a min term, right? Yes or no? See what we got? We got function f, that is x, y, z, w. Okay. This function f we got, that is x bar, y bar, z bar, or x bar, y bar, w, or x, y bar, z, w, x, y bar, z, w, or x, y, z, w bar. Okay, so this is what we got. Now here you can see that this is already a min term. This is your min term number 14. Okay, there is nothing to do here. This is already a min term. This is already a min term. This is your min term number 11. Okay, what about these? See, this is not a min term, right? Yes or no? Agree? This is not a min term. This is a product term, but this is not a min term. This is a product term. This is a product term, but this is not min term. But not min term. Why this is not a min term? Tell me why this is not a min term? Because in a min term, every variable must be there. Okay, min term is a product term containing all the variables. Okay, so this is a product term, but this does not contain the variable w, because variable w is missing. I can say variable w is missing. Okay, the same thing happens here also. Variable z missing. Here also variable z missing. Okay, here variable z is missing. So this is the point. Now what you can do? Very simple. If this variable w is missing, so this product term will express two min terms. Yes or no? This product term, this will express two min terms because variable w is missing. So either you can put it complemented form, or you can put it without complement, So tell me, two min terms you got. You got two min terms. So tell me, the first one, this is min term 0, and the second one, this is min term 1. Two min terms you got from here. What about this one? Again, you got two min terms. Remember, variable z is missing. W bar, y bar. Variable z is missing. Okay, see, x bar, y bar, w. Now variable z is missing. So you can put it in the complemented form, or you can put it without complement. You can put it in the complemented form, or you can put it without complement. So tell me, which min term you got here? Which min term you got here? Min term 1. And which min term you got here? Min term 3. Okay, so min term 1, min term 3 you got here. So finally, for this function, what are the min terms? X, Y, Z, W. What are the summation of min terms? What are the min terms that we got? So we got 0, 1, 3. You can see we got 0, we got 1, we got 3. 0, 1, 3 we got 11, 14. We got 11, we got 14. Okay, this is your answer. 0, 1, 3, 11, 14. So this should be the answer. 0, 1, 3, 11, 14. 11, 14. So answer will be option B. Yes or no? So the answer is going to be option B. So this is your GATE instrumentation 2021 question. A very simple question. The answer will be option B. Okay. So we have done all the questions, all the GATE, you can see GATE electronics, GATE electrical, GATE instrumentation, multiplexer questions we have done. So what we have done, let me tell you, we have done GATE electronics, GATE electrical, GATE instrumentation. From these, we have done multiplexer questions. All the questions that we have done, these have already come in the GATE exam. All the questions that we have done, these are already GATE previous year questions. Okay. So please tell me, did you understand all the questions? And did you find some confidence? I can say, are you feeling confident in the multiplexer topic? From this multiplexer in the GATE exam, whatever question comes, will you be able to solve? And will you ever forget? See what I'm saying. we have done 15 questions from the multiplexer. 15 gate questions we have done. Okay. Did you understand all these questions? And also, did you understand this multiplexer very clearly? In the gate exam, in gate computer science, if any question comes from this multiplexer topic, will you be able to solve? Are you confident? Please let me know. Okay. So I hope you liked the session. This was a very interesting session because we are solving the gate questions. Okay. Whenever we are solving gate previous year questions, we always enjoy. Okay. So these are the questions that we have done. I hope you enjoyed. Okay. Thank you, everyone.